Welcome to the knowledge sharing session. This is the second part of the knowledge sharing series that I started last month. In this session, we are going at the beginning for about 15 to 20 minutes. We are going to look at some advanced ideas and concepts that an engineer, a team might need to implement microservice implementation, and that is platform independent. In the second half of the knowledge sharing session, we will take a look at that how we can actually implement a microservice system depending on the concepts that we have seen in the previous knowledge sharing session and that we are going to see. And since I'm a .NET developer, I do not know how to implement microservice in other platforms. So I have to show you in .NET. But since the concept is applicable to all platforms, so I hope even if you are not a .NET developer, you will be able to take something out of it that in your real life implementation of microservice. So let us get started. We start with the code. In vain have you acquired knowledge if you do not impart it to others. I put it there because before coming into Cephalo, I saw in the internet and heard from people that Cephalo hires the best developers in Bangladesh. Well, I have known some very brilliant developers in my last 1 month in Cephalo, and I'm fortunate that I'm surrounded by bright, brilliant mind. And but it will be of no gain if we do not learn from each other. So the agenda today, we are going to look at the microservice topology, this topology of a microservice system. I have shown you topology, and in the last presentation, you have also seen the topology of a microservice system or a part of it in the last session that we had from another engineer from Polash Bhai's teams. So we are going to extend a bit on that. Then we are going to talk a little bit about domain-driven design and what are the key points that you need to pay attention to. Then we are going to take a little bit of techniques that is used in dependency injection and the IOC container. That is like how you can like inject things and inject out, that sort of thing. It's very common in most modern platforms, so it's not unique to .NET, I think. Then actually we will take a look at two different architectures that you can use to build microservice. Both of them are popular and used in the industry. The first one is the good old N-layer code first microservice. I believe that we are all more or less familiar with N-layer architecture. So we are going to take a look at that, how it can be used to build a microservice. And we are going to also take a look at clean architecture with CQRS. And we'll see code that how it can be implemented in the code and put into use. This is a bit newer and a little bit of what I would say, glamorous concept of implementing microservicing. Clean architecture and CQRS. Then we will take a look at microservice to microservice communication using a message broker. And we will discuss a little bit about how you can implement it because there is not a single message broker out in the market. Then also we'll take a look at service resiliency, why it is important, and what technology is out there that you can use to build it. The implementation part is where we take a look at the code. All right, let's get started. The topology. So in our last lecture, in last two sessions, we have seen that Microservices are smaller independent services. They run on containers that is separate from each other and sitting inside a container cluster or maybe outside. And each microservice should have their own database, right? So this is a topology that you can see that it has 1, 2, 3, 4 microservices. Each microservice is connected to its own database. And this whole system is sitting behind a gateway together with the aggregator, which has its own database. Now, what is an aggregator? Many of you already know, and we will actually see the use of an aggregator when we take a look at the implementation. Aggregator is a very important concept of a microservice system because there are several things that there are scenarios where you might need an aggregator. Just 2 weeks ago, I was having a discussion with Polash Bhai, and we were discussing that how aggregator can be used for a particular business scenario. So actually, in real life, you'll see many use of it. And then we see that how, I mean, microservices can communicate to external system like Azure Blob or something else. It could be gateway to something else, like you send message through the what is that server called? Twilio, using for SMS and SendGrid for emails and that kind of thing. Now, pay close attention here that my identity microservice that is used for authentication of users. That means how the microservice system works. I mean, generally, a microservice system will work like that. First, a user, the client, maybe you're running an Angular client or React client, whatever client it is, first you send a call to the identity microservice to get a token, right? Because these HTTP calls are mainly token based, because I'm not going to show you how to build a stateful microservice in this lecture. That's for the next. So this identity microservice, this is something you call to get your token. You send a request to it, whatever flow that is using, maybe the auth tools, that simple username password flow, or it could be more complex, something like implicit or that authorization code Pixie. So whatever it is, the authentication, I mean, the user is authenticated here. And then the token is dispatched to client, and the client used that token to make a call to the microservice system. The authorization happens in the gateway, or you could choose to do it when the call is routed to the microservice, but best to do it in the gateway before the call is routed. There are several things that you have to pay attention to, but I have seen systems where the authorization is not done in the gateway, but in the microservice itself. But I don't claim that that is a very good system. Anyway, the standard data flow should be flowing like this. The call first comes to gateway, then the gateway transfer the calls, routes the calls to the appropriate microservice. Now, many of you are thinking that since this is an internal communication, why we don't use gRPC or that kind of thing? Well, some people have actually used it. Not that no one did. Like when, especially during the use of aggregator, when aggregator sends call to other microservices, gRPC is used. But we'll discuss that later. This is the general topology of a microservice system. We will see it in use. Now, for the API gateway, there are famous technologies out there. So you have seen an implementation of Ocelot gateway in the last presentation session, last knowledge sharing session. I'll also use Ocelot. But there is the newer Envoy, which I think is more fancy, and it is written in Go, so people like it. But I haven't used it yet. But, if you want, you can use it, of course. Hope everyone is clear so far that the main purpose of showing the topology is that because so that you can understand that what is the gateway and what is an aggregator and what is the use of it. The aggregator, by its definition, it aggregates all. So what happens, suppose there is a scenario that you need to access 2 microservices or 3 microservices, that means more than one microservices, to generate a result. It could be a post command or it could be a get call, but suppose you need to access more than one microservices, then what we'll do? Are we going to route the call to one microservice, then one microservice is going to call the other? No, we don't want to do that, because microservice to microservice HTTP direct call should be avoided in your system as much as you can. Otherwise, it will end up in having dependencies in these 2 microservices, and there are a lot of problems with that. So it is better that you use the aggregator and build resiliency in your microservices so that your call doesn't fail, or there are proper systems in place to handle the fault. We'll see that in implementation, how it is all done. So moving on to more interesting things, domain-driven design. So we have discussed a little bit that how do you define your domain? To build any microservice system, first you have to define your domain. Then you build the microservices on the top of your domain. So how a domain can be identified, I mean, it should be actually the smallest set of entities. If it is a domain can be made with 1 entity, do that. But making a domain solely with 1 entity is a little bit of problematic. You will know why, because suppose you have 2 entities like voyage and birth, and they are in 2 separate microservices in totally separate domain, then what we will have that you will have to exchange data in between them too frequently, which is not good. But be very, very careful when you create your domain. So the main objective of showing this is that the things that you need to pay attention to when you are designing domain or creating your domain in code, because this is the implementation. You need to understand what is entity, what is value object. Entity is a general concept. You all understand what is an entity. It could be an order. It could be a payment that is directly related to business. So domain-driven design comes from the business model. So entities are real entities that relates to business. Now, what are value objects? Value objects are objects that does not have an independent existence inside the domain, but always together with entity, it is meaningful. Suppose if you use the date time object with an order entity, so that is a value object, because a date time by itself has no meaning, but together with the order, it has meaning. Likewise, you can take a look at this differences or similarities, what you call between entities and value objects. Actually, you don't have to take read these things and get it's a worry about it. When you see in the code, it is much more easy. I mean, sometimes things look very Greek in when it is written in books or presentation. Right. So next thing is important is aggregate. So any domain-driven design depends on the aggregate. So the understanding of aggregate is very important. So what are aggregates and aggregate groups, right? So it sounds very complex. Actually, it is not. Think about it in this way. Suppose you, what is the basic of OOP? The basic of OOP is that an object will encapsulate its behavior, right? An object will encapsulate its behavior. So you see, I mean, last time when I was doing knowledge sharing, I discussed a lot about anemic design pattern. That is an anti pattern when the objects do not encapsulate any business logic. And its validation and behavior and all the business logics is implemented in the service layer or in the command classes or query classes. So that is actually not a very good design, because that will, if you do that, what will happen? Suppose you're writing a command class, a service method, and then you are implementing another event, then your business logic will get segregated. So the best way to do is that you create an aggregate and encapsulate all the business logic inside the aggregate. We'll take a look at it. Don't worry about it. Don't worry about it. It's not a very complex idea. It's actually quite easy. The aggregates have aggregate roots. That means when an aggregate could be a cluster of entities, or it could be an aggregate could only have one entity as well. It doesn't mean that an aggregate always have to be a cluster of entities. Could be one entity. We'll see how that happens. Right. This is a UML design I have tried to put in so that you can relate to it. The people who understand, some people understand UML better. I guess more like business-minded people. They prefer to have things summarized in UML first, then to code. Well, it actually makes sense. But if you are not a UML geek, you like code better, so then you actually don't have to look at it. I will show you in the code how the aggregate and aggregate root is handled and what is the concept. Okay, so that's pretty much about aggregate, DI and IOC. GI is the dependency in the DI container. In .NET, starting from .NET Core, we have the DI container. There is a built-in IOC container in the .NET, and also you can use the more advanced IOC containers like Autofact. So the main reason that the DI container has a lot of use, like it depends, resolves service dependency and that kind of thing, and you push things inside it. So the main objective of showing you this, that how you can use the built-in IOC container and how you can use the Autofact that is more advanced. You can plug it into your system. And what advantages does Autofact present to you? So Autofact gives you some advantages over the built-in IOC container, because the built-in IOC container is relatively simpler. First is the service lifetimes. So you see, generally you use this 3 kind of service lifetime for objects inside your built-in IOC container. But Autofact also offers you the other service lifetimes that's not available in your built-in. This one is better actually. Yeah. So this single instance is equal to like the singleton. You all understand what is a singleton, scoped and transient lifetime for an object. It depends on the HTTP context. I'm not going to discuss it here because most people already know it. But what is interesting is that Autofact gives you some other lifetimes as well. Honestly, I haven't used them, but they are available in Autofact. So you can go ahead and play with it. And if it suits your system, you can actually use it. Not only that, Autofact has some other uses. It is interesting. We'll see when we take a look at the code. So moving on, this is a very important part. Now we discuss the layers and structures of microservices. So first is the N-layer microservices, pretty straightforward. You have the data access layer, where you have DD context, repository, domain models, everything related to data. Then you have the application service layer where you put your business logic and everything. You call the repositories. And on the top of it is the presentation layer, which is your API controllers and event handle, of course. So, but what is, common in an N-layer microservice, that one layer is pushed into another, right? As dependency injection. That is how you will use it when, you obviously do not want to create an instance of DB context or application service inside your API because that will put hard dependency. So it's a very simple structure. First you create this layer, then on the top of it, this layer, on the top of it, this layer. It's very straightforward. There is nothing complex about it. We have seen it over and over, even when we did monolith. We'll see how you can use it in microservices when we look at the code. Clean architecture, on the other hand, is a bit of fancy. So from experience, I can tell you, actually, clean architecture is difficult to build when you are coding it. It takes longer, takes more time. But it is a lot easy to maintain. When your microservices, business logic, and everything goes expanded and more and more complex, if you are using the N-layer architecture, that actually becomes difficult to maintain your code. Maintaining clean architecture is a lot easier. So let us take a look at the clean architecture. It says that domain and application will have to be in the middle, and infrastructure, that means DB context and other things, and presentation, that means controller and other things, will use the application and domain from outside. It is not one upon another. So how it can be done, we will see in the code. So it looks like an onion, like the onions have layers. So some people call it onion architecture. All right, CQRS, you have heard about CQRS. It stands for Command and Query Responsibility Segregation. So, okay, it's a fancy name, but what does it mean? Well, it actually means this, that there are systems where you use two separate databases for write and read. And not only that, you might not use two separate databases for write and read, but you can simply, totally separate your query and command logic. So how we can do that, we will also see in our implementation. So why one would want to use the separate databases for write and read? So the common idea is that if you are using unstructured database like MongoDB or Azure Cosmos DB, no SQL database, it is easy to write data there. It is faster to write data there. And on the other hand, the relational database like SQL or Oracle or something else, that will be easier to read. Running a query on a relational database is easier. So this makes the microservice faster, but not only that, it has other uses. So that is the general idea, that you totally separate your command and queries. By the way, query means generally translate to your get calls, like get list or get a single entity. If you translate it to, HTTP, query generally means your get calls, and command generally means your post, put, and delete calls, so that we can easily relate to it. Okay. Microservice and to microservice communication is a very important part. Now, we just talked about aggregator. Aggregator is a special, you can think about aggregator as a special microservice that will actually call multiple microservices and then build a result, right? So what happens that if a microservice wants to directly need to replicate data or communicate with another microservice, In this scenario, generally what you'll do, you'll use the asynchronous method, because making direct HTTP call is not a very good idea for many reasons. So you'll use a message broker or something like that. Some people use event streams. I never have, but you'll use message brokers like RabbitMQ or Azure Service Bus. I have used Azure Service Bus and RabbitMQ. I have never used Kafka, but some of you might have. So you understand that what I'm saying, the two microservices, when they communicate between each other, suppose this order management microservice need to call the payment microservice, you should not go to make direct calls to its API or to its database. It is always better to publish a message in the message bus to which the payment will subscribe. In this case, I mean, there will be no direct dependency to these microservices, but of course, you have to take the latency in count. There is the CAP theorem that is applied to microservices about replicating data to all of its nodes. It's a more advanced concept. We'll discuss it in the next knowledge sharing session. So how message passing can be done, we'll take a look at it when we see the code. Service resiliency is something you need to build in your microservice, because while your microservice have to be up, since it is a distributed system, so it will not totally go down if one microservice goes down. It will still function, unlike a monolith. Like a monolith goes down totally when even a part of it goes down. A microservice system is not like that. But it might not be a fully functional system, right? So, and most of the SLAs that we sign these days, your customer will put a condition that it has to be up like 99.9% time. So what do we do? Because we built our microservices with the assumption that at some point it will fail, right? The system in mind, when we build it, in mind, we have this thing that it will at some point fail. So we build fail safes. We build systems that keeps the service up, or we can handle the damage quickly, damage control. So how do we do that? So how do you do that? One part of it that you continuously check the health, you monitor the health of the microservices, your entire system. That's very important these days because it's a distributed system. So you have to have a way to take a look at the entire system at a glance. Also, what you do is you can use that retries and circuit breakers. How we do that, we'll take a look at the code. So now it is time to take a look at the code. So my microservice system is running in Docker. The container orchestration is running in Docker. But I mean, in production, you will not be using Docker Compose. You will be probably using EC2 or Kubernetes, Azure Kubernetes service. So how to design pods and clusters in Kubernetes, that is not within the boundary of this knowledge sharing. If you want to, because that is more DevOps related. Like how you can create the infrastructure in production and how you can build pipelines like CI/CD pipelines. If you want to have another knowledge sharing session on that, please request it to management. We can arrange it later. But for our use, I have built two microservices that is interdependent, my order microservice and this order management microservice and payment management microservice. So these two microservices are interdependent, and the request actually passes through the Ocelot API gateway. So here you can see this is a code of a Ocelot. I have already shared the code with management. So if any of you want to take a look at the code in more details, you can do that. Ocelot is a pretty straightforward way to build an API gateway. You saw it in the last knowledge sharing session as well. So it like forwards the call. First, the call comes into the gateway, then it's forward to the microservices. Now, if you take a look at my Docker Compose, you can see this is my Ocelot. It is running on a container on a port that is bound to 5105. So what will happen if I write I have to copy a little bit from my okay. Sorry about it. I was about to build this, but then so now see, this is my microservice order microservices API. It's a controller, right? The HTTP post controller. Let's send a post request to it and see what happens. So you see the post request is hitting the breakpoint. So I have received my order request. I have received a post request based on order. Now this is the controller. Now see, interesting is that this is a CQRS style microservice. So CQRS style microservices have separate command and query. That means this is a post command. So it will, I have used this mediator that actually resolves the command. So what is interesting about this CQRS is that you do not have to push the command and queries inside your controller. You see, there is no service class here. I only have the mediator. The mediator actually resolves that what command and what queries to call. So it will be transferred to this upsert order command. So my command class is here. And it has a handler, right? So now you see that the command has been passed from controller to this command handler. This is the command class, and this is the command handler class. So this class is not pushed into controller, but through mediator, the command has been resolved. And now this command class will create an order in the order microservice database, but at the same time, it will also publish an event to my message broker. When the event is published in my message broker that an order has been received, so now a payment will be auto-created. I do not have to call the payment API. because the payment microservice, which is in fact an n-layer microservice, you can see there are 3 layers: data, application service, and payment API. So this one has an event handler, and it subscribes to that event. So it will actually use this call to create the payment. So this is what is happening here, the microservice to microservice communication using a message broker, right? So to use the message broker, you have to first create the, I have used this way. I didn't directly call the RabbitMQ. What I used, I used an abstraction in form of iEvent bus interface. My iEvent bus interface actually wraps on the top of RabbitMQ, right? So the fact is, my microservice system is actually oblivious to what kind of message broker I am using in this system. It only understands the interface, and it calls the interface. Now I could use Azure Service Bus. In that case, I'll have to use this iEvent bus interface, and I'll implement a class, another class, like this is this class is wrapped around, encapsulates the RabbitMQ. I'll be encapsulating the Azure Event Bus. Because I believe, like a lot of people, I mean, who use Azure as cloud service, they will prefer Azure Event Bus over RabbitMQ. But anyway, so yeah, let's go back to our order command. We release it. So see, the order has been created, and now we are going to publish a message in the message queue. We do that. And now the payment microservice, this class, here. This one has subscribed to that event, and the event is being created, and a payment is being created. So if I make a get call, so you see my order has been created. Okay. So let's see what about the payment. And my payment has been created as well. So how about I send another call. Same way it goes. Yeah, I received reply. 2 orders and 2 payments, right? So now let us take a look at what if, like you see, my payment entity doesn't keep any record for the order. Sorry, the order entity doesn't actually keep any record for the payment, right? Let's take a look at my order entity. This is my domain. The order doesn't keep any record of the payment number, I mean payment ID, but the payment entity does. So if you have such a call like this, 1 second. Let's take a look at my oscilloscope. Yeah, so about this call, how this call is being handled. Put a breakpoint here. So what it is calling a payments order because it needs the order ID together with the payment ID. Now the payment entity actually doesn't have the order ID, right? It has the order ID, sorry, but it doesn't have this information, ordered by who. How do I know? Okay, let's take a look at my payment entity. See, my payment entity data fields actually keeps track of the order ID, but it doesn't know the order by. Order by, that information is within the order microservice database that is here, right? So now the, all right, I probably should show you the microservices databases. Anyway, when it comes up, it's a lot of things probably to take it in a single session, but you are welcome to send me questions afterward as well. And we'll be taking a deeper look into it in the next session because I'm going to show you the DAPR thing. So what happens when this call is intercepted by the aggregator. Now aggregator will do what? Aggregator will first make a call to the payment API. It will make a call to the payment API, then another thing, and don't do this in your code because this code is not actually production yet. I have just done it to like show you how things can be done, but it's not really production level code. So it got the data of payment using the payment ID parameter that was passed to it from the payment API. Now using the payment order ID, it will make a call to the order API. So what is happening? It is actually calling two microservices. The aggregator is first calling the payment, then the reply comes back, then the aggregator is calling the order. So, and this is how it is getting data from both microservices, building a result and sending us back. Now, this is a get call. Now, you see, you can use the same thing to create your post request as well. Like when we created order, what we did, we used message bus. We used the message broker to send this event. Now, let us take a look at this, what is happening here. What happened here? When we made the post call to order management, the gateway directly routed the call to the order management, right? Then order management did what? Created the data in order DB and published a message to our message broker, which is not Azure Service Bus in my case, it is RabbitMQ. And then payment management subscribed to it, right? Now, you see that very easily we could have done this with aggregator. But when you are making such a call, you are using aggregator or something else, you have to take into account the latency because it takes time for the aggregator to execute because it is using multiple web microservices. So when you are designing your microservices, you have to make a choice. You have to make a choice between the availability, performance, and this kind of thing that is discussed with the CAP theorem, which we will take a look at in the next lecture. So that is pretty much it. And let's take a look at the startup. Well, actually, it's this .NET 6 does not have startup. So I'll show you very quickly how you can build resiliency. So create resiliency, you can use Poly. So Poly will use this kind of retry policy and circuit breaker policy. So a retry policy is what? Like when you have called a microservice, suppose this call. This method actually makes this HTTP client and it makes a HTTP call to a microservice. So what if this microservice is down? In that case, you have to, in general programming, what you will do, you will apply a polling. You will call it again and again. And at a certain point, you will break. In old days, we did it with loop counters and polling. We called it polling. But in modern code, you don't have to do it in this way. You can simply define your retry policy here with poly, and this will actually do the retry. I will show you like this. So what if I turn off? I paused my payment API. Let's remove this. Ooh. So what is happening? Actually, this thing will now retry multiple times before failing. So that is how you can tell the poly that how many times to retry and everything. I release it, and the result will come up. But you also might want to use a circuit breaker. The circuit breaker is another thing that there are often this scenario that you do not want to retry. Because think about it, like if one microservice is down and there are many microservices that is totally retrying to call your down microservice, it will not actually make situations better in all cases. So in that case, you might want to use the circuit breaker, but I haven't used circuit breaker. It is, I'm just showing you. In this system, circuit breaker is not implemented. But we can have sessions or knowledge sharing or whatever later, because these are detailed things. There are very, very complex retry policies and resiliency you can build with Poly. Another thing is like building your using here. Sorry. Yeah, using Prometheus and Grafana to actually monitor your microservices. So that's also pretty easy. What you have to do, like you have to add the Prometheus client here. If you add the Prometheus client here, the client will actually collect a few data, and then you can monitor the data from your Prometheus. So where is my Prometheus? My Prometheus is hosted on a container within the same network, and you can also use Grafana to like make the data look better. So let's take a look at my Prometheus. So this is my Prometheus. Let's see. No. Here it is showing data now. Let's take a look at the graph. It is showing you on the graph that whatever the health of your microservice is. So how does it happen? What actually happens that you have defined, I mean, most of you have already used the Windows event counter or that kind of thing. It is pretty similar. So you define your Prometheus here. So my Prometheus actually only targets the aggregator API. You can use it for all your microservices. Doesn't have to be one container only. So let's go to my aggregator. So my aggregator has actually used this middleware. So this middleware does what? It has some pre-built counters. It has some pre-built counters, but if you want to add new counters, actually you have to code them. And how you have to do that, there are tutorials I can direct you to that how you can do that. But it actually wraps a very few simple built-in counters. And these counters are being delivered to the Prometheus container, and the Prometheus is converting them to a graph. Now see that this graph actually doesn't look very good, right? It is showing you the data, but it looks very simple. So that is the reason a lot of people will use Grafana. Let's take a look at my Grafana. So I think it is supposed to be my user manager. It's the default password. Maybe there is something wrong there. Should be. I don't remember that I changed it. Anyway, so what actually Grafana does, Grafana can collect to your Prometheus and it offers you better graphs. And there are some better data analytics tools in Grafana. So that is what it does. But in my next knowledge sharing session, you will see that there are actually better data analysis tools available. So not that you always have to use this thing here. There are better, oh, I lost my share, I think. Yeah, so because I personally do not like Grafana very much. Prometheus is a good tool, but for some reason I didn't like Grafana. And nowadays you don't even have to use Prometheus if you are using .NET platform. there are other things, other tools that you can use. I'll show it to you in the next session. So let's go back to our slide. What we saw here, we covered pretty much everything. I'll just end with a little bit of discussion with this architecture. So this is the clean architecture. So now you see, pay close attention to these two microservices and their layers. So you see that domain layer, the domain layer actually defines the entities, and then domain layer is used by application layer. Now your question is how the hell is the application layer is using the domain? It has an interface. The interface actually defines your DB context. And all the command and queries and the business logic, then everything that you are writing, it actually is dependent on this interface. Now you could ask me that what if I use a repository? I use separate repositories for command and query. Yes, you can do that. So you can do that. You can create separate repositories for command and queries, and then you will be you don't have to define this interface in your application layer. Then this application layer is used by persistence, which is actually part of the infrastructure. That means the DB context and other things. And it is also used by the API. So now your question is that since I'm not using command and queries, I'm not pushing command and queries into the controller, then how it is being done? It is actually, we are pushing the mediator. The mediator pattern actually, when the call is diverted, call is submitted to a mediator, the mediator, as its name suggests, will resolve your call, like which command or queries to call. So that is how it works. And this payment management microservice is a simple n-layer microservice. If you take a look at this controller actually has the service class, right? It is being pushed into the controller. So this is simple n-layer microservice. And if you go to the service here, repository is being pushed into the service. So one on the top of other. So that's it. Nothing complex or anything about it. And we'll take a look at the domain design. So what I was telling you, that when you design your entities, your logics have to be encapsulated by the aggregate. So this is an aggregate. But this is an aggregate that encapsulates the logic and behavior. You see the business rules. The business rules. So now, like, I don't have any business rules here, but it should go here. I have just used the constant, but you get the idea. So it is the business rules, logics, and validations are and should be encapsulated by the aggregate. Now you might wonder that this is one single object. Yes, it is one single object, but what if I had an address class and I was using address as a value entity, value object? Now here in the submission date, I have used date type. Now this is a built-in type, a built-in class, right? But here this is used as a value object, because independently submission date time has no value. Together with the order, it has value. Another thing is, I want to show you the mapping that I have done here. I have used DTO, this is called the data transfer object. But in my data transfer object, I have created mapping. Some people do not like it. They want to wrap the creation of the object, especially through a constructor. I'll tell you the difference. The difference is this. Take a look at here. My order is being created, this is for when I'm creating a new order. So its parameters are not being passed using the order constructor. Okay, it's not being passed to the constructor. Actually, I'm creating an empty order. Then I am mapping the data to the order. Now, this is something is not a very good. This works very well for anemic design model because the logic is handled within the command class. But actually, when you are creating order, you have to have two constructors. I just didn't write it. One that takes data and one that doesn't. But mapping is obviously important because if you are updating the entity, then you'll always have to map data. So how the mapping is done, I have used AutoMapper. You can choose not to use AutoMapper or something else. But anyway, that's pretty much what I had to share. And now we'll quickly do a little bit of question answer session if you want to ask something. I know, I mean, if you have built microservices, it's easy for you, but if you haven't, it's a lot of things to take in. But actually, I'm telling you, it's quite easy. It's no rocket science.